Now, I will take that once again this example left, because there are some complaints from the students who have not understood that one. So, once again I am taking this example. F is a function from R to R, be a signum function defined by f of x equal to 1 for x positive, 0 for x equal to 0 and minus 1 for x negative, and G R to R is a greatest integer function which is f of x equal to square bracket x. So, here f of x equal to square bracket x, then does f composite g and g composite f coincide in interval 0 1 semi closed interval 0 1. So, first I take f composite g of x, so which is f of g of x, and f of g of x means f of, sorry, here this is g of x is square bracket x and its value in the interval 0 1. So, I write this, you know that when we have any value between 0 and 1 in the open interval, or we can take this as 0, you take 0.5, 0.9, 0.8, always its value is nothing but how much? It is 0. So, I write 0 for all x greater than 0 means this implies x belongs to interval 0 1, and when x is exactly 1 means it is square bracket 1 and it is 1 for x is equal to 0. So, this implies f composite g of x is 0 for all, sorry, if still we have to complete that one, this is f of 0 and this is f of 1. Further, f of 0 now, look here, f of x positive means any value between 0 and 1, its value is 0, and for x equal to 1, its value is f of 1, square bracket 1 is 1. Now, f of 0 means when x is 0, see here modulus function is 0 for all x belongs to 0 1, and for x equal to 1, x equal to 1 means it is also at exactly 1, it is also 0. So, for x equal to 1 means I write this as f composite g of x, which is 0 for all x belongs to the interval 0 1, and we do not take this as x equal to 1 because it is only one value, or let us write here, and f composite g of x is equal to 1 for x equal to 1. This I can write as 1. Now, I take g composite f of x, which is g of f of x, and g of f of x means so it is two value when x is positive. So, this I write as g of f of x is, see here, for x greater than 1, f of x is 1 it is, for x greater than 1, 1 it is, g of 1 it is, g of 1 for x greater than 0 means that is nothing but x belongs to which interval it is 0 1, x greater than 0 means it is in the interval 0 1. We do not take x beyond 1 because our interval is 0 1. And next for x equal to 1, for x equal to 1 means it is also the value in the interval x greater than 0. So, I write here g of 1 for x is equal to 1, and after that g of 1 means it is square bracket 1 for all x belongs to interval 0 1, and it is also what is that 1 for all x belongs is equal to 1, means this is 1 for all x belongs to 0 1 and 1 for x equal to 1, means I write here G composite f of x is equal to 1 for all x belongs to the interval 0 1. This is your 2. Observe here, for 1 in the interval 0 1 we have f of composite g of x is 0, and for interval 0 1 g composite f of x is 1, and these two are not equal, since 0 is not equal to 1. So, this implies f composite g of x is not equal to g composite f of x for all x belongs to 0 1. So, this implies f composite g and g composite f does not coincide in interval 0 1. Now, after that the next example which we have left, we have to take this one, 7th one I had left. Now, I take f of x. So, f of x means I put this value x square minus 3x plus 2, and this I can take as f of y. I have taken for the sake of convenient, since y is what we have taken x square minus 3x plus 2, just for the sake of convenient I have taken. After that again we can replace the value of y as x square minus 3x plus 2, and this f of y means put here x equal to y. So, we get y square minus 3y plus 2, and I put the value of y which is here x square minus 3x plus 2 square minus 3y means it is x square minus 3x plus 2, and this is plus 2. I square this, you know that a plus b plus c whole square, which is a square plus b square plus c square plus 2ab plus 2bc plus 2ca. A square means x square whole square is x raised to 4 plus 9x square plus 2 square is 4. 2ab means 2 3s are minus 6x square x cube, 3 2s are 6 and 6 2s are 12x, and 2 ca means 2 2s are 4x square. This is square of x square minus 3x plus 2. I multiply minus 3x square minus plus 9x minus 6, and this is plus 2. Add all these. First of all, x raised to 4, after that minus 6x cube, and see here 9x square, 4x square is 13x square, minus 3x square means it is plus 10x square. After that minus 12x plus 9x, which is minus 3x, and 4, this is 4 plus 2 6, and this minus 6 get cancelled. So, this is f of x. This is f of x. After that Next example, we have completed up to 12. After that, I take this 13th example. 13th example, if f of x is equal to 5x plus 3 divided by 4x minus 5, and here x is not equal to 5 by 4, because if x is 5 by 4 means 4x equal to 5 means 4x minus 5 is 0, means it is not defined. So, yeah, x is not equal to 5 by 4. Show that f composite f is a identity function, and what a identity function is? X it is, where x belongs to a real number. Now, I take f composite f of x, which is f of x. I put this value f of x is 5x plus 3 divided by 4x minus 5, and as we have done here, let us take this as f of y, where y is 5x plus 3 divided by 4x minus 5, and this equal to f of y means put here x equal to y, which is 5y plus 3 divided by 4y minus 5. This equal to, I put the value of y which is here, 5 into y is 5x plus 3 divided by 4x minus 5 plus this 3 divided by 4 into by means 5x plus 3 divided by 4x minus 5 minus 5. I multiply nr and dr by this denominator 4x minus 5, multiply and divide by 4x minus 5. So, here 4x minus 5 get cancelled, 5 5s are 25x, 5 3s are 15, plus 3 into this 4x minus 5 means 3 4s are 12x, and 3 minus 5s is minus 15. After the denominator, this 4x minus 5 get cancelled, 4 5s are 20x, 4 3s are 12, minus 5 into 4 means minus 20x, minus minus plus 25. So, 20x denominator get cancelled, so 15 get cancelled. So, 25x plus 12x is 25x plus 12x is, it is 37x, and 12 plus 25 means it is 37, 37 get cancelled x, and this is your identity function. After that, next example, which is here, this 14th example. See that find G composite f composite G if f is a function from R to R, G is a function R to R given by f of x equal to cos x and G of x equal to x square. Show that f composite G is not equal to G composite f. First, I take f composite G of x, which is f of G of x, and this is f of G of x means it is x square, and f of x square means, see here we put x equal to x square here, means we get cos of x square. This is I take as 1. Now, G composite f of x, which is G of f of x, and this is G of f of x means it is cos x, and G of cos x means put here x equal to cos x means it becomes cos x whole square, and it is cos square x. This is your 2, and we know that since cos of x square is not equal to cos square x, means this implies f composite g is not equal to g composite f. So, this is the last example of this composite function. So, we have completed this composite function. So, next part of that chapter is inverse function, and so in the next session we shall take that inverse function and we shall discuss inverse function, and on the inverse function you are getting one question for 5 marks, and that is the first question in part D, and it is 39th question which carries 5 marks. And after that one more small part is left, binary operation, and after completion of binary operation, this is then that is the end of the chapter relations and functions. So, in the next session we shall take inverse trigonometric function. Okay, dear friends.